Good afternoon, everyone, and welcome to today's webinar. Today, we're going to be discussing fire protection and life safety for historic preservation and adaptive reuse. With us today, we have Scott Volkerding with Osborne Engineering. Before we get started, I just wanted to go over a couple quick items with everyone. First of all, we'll be taking questions at intermittent breaks today, since this is a pretty deep and heady topic. So we'll be giving some breaks out. So if you have, as you have questions, please type them into the Q&A box, and we'll be taking breaks every so often to get those questions answered. And if you have questions at the end, we can answer them as well then. Also, if you have any issues with the webinar today, just please close the webinar out, click the link that was sent to you. That'll solve 99% of your Zoom related issues that you'll be experiencing. So today we have with us, as I just mentioned, Scott Volkerding. Scott is the director fire and life safety at Osborne Engineering. He has technically experienced in many aspects of fire protection and engineering, including fire building and life safety code consulting, hazardous material storage, due diligence studies, and various design concepts for fire protection systems, fire alarm systems, sprinkler systems, smoke control systems, means of egress, and other life safety systems. Scott has managed a range of projects from engineering studies to blank purchase agreements for fire protection services. He is a member of the National Fire Protection Association and an associate member of the Society of Fire Protection Engineers. Before we get started, I just want to mention also we do have AIA credits thanks to Osborne Engineering and Scott here today. So right now I'm going to be putting that in the chat so all of you have access to that. You can fill it out. I'll remind everyone at the end as well to fill this out. But without further ado, I'll turn things over to Scott as I get this sent out to everyone. Thank you.
Thank you, Devin, and thank you to Heritage Ohio for arranging this webinar today. I first rolled this out at the conference last October, and happy to do the webinar. And thank you guys for all attending today. We're talking about fire protection and life safety for historic preservation and adaptive reuse. Thank you for the bio there, Devin. A couple other things I want to hit here. I just joined the Association for Preservation Technology Committee. And we're working now on ICC code change proposals with that group. I've been in the business more than 20 years, doing work all over the country, registered in 28 states, and dedicated full-time to fire protection, life safety, engineering. Osborne has 10 full-time fire protection and life safety engineers that are waking up every day focused on this topic. So a couple of learning objectives today. We're going to talk about some of the inherent fire protection challenges for historic structures that we don't deal with in other project types. There's many code standards and guidelines that govern the work. We'll touch on those. And also how to take a holistic approach to fire protection and life safety and all the different things that go into the level of risk in fire protection safety. We're going to review different compliance methods for existing buildings that are driven largely by the building code. We've got a couple case studies to share on how to deploy some of those tools, and then some other additional tools that we can use beyond the codes and standards as we get into performance-based design and more specialty type services and work. The inherent fire protection challenges of historic structures, in some cases, these are hard to replace, not only the buildings, but the contents inside. And of course, preservation of cultural heritage is also a big part of that. But these facilities also have inherent higher fire risk and additional challenges for life safety, due in large part because of the codes and standards development that lags. We learn a lot of our lessons from fire history, and a lot of times we'll have a big fire and then it'll take 3, 6, 9 years to get some of those lessons learned into the codes and standards that we use for development of the building. So as we're looking at old buildings, whether it's an adaptive reuse project or an old building for a renovation or addition project, we got to keep in mind that the buildings may have been built 70, 80, 90 years ago when there was little to no codes. Just a brief ICC history. Almost all jurisdictions now in the U.S. use some form of the ICC. There are exceptions to this, but and states take those codes and modify them. But most jurisdictions are using a national model-based code. And there were 3 at one point that were all condensed down into the ICC in the late 90s. And were first published. The original International Building Code was published in 2000. The existing building code, which we'll be talking about today, was published in 2003. And these are revised on 3-year cycles. And As I mentioned, the states will take those and modify those, and they don't always pick up every cycle. So here in Ohio, we just moved from the 2017 edition up to the 2024 edition, and that's not atypical as you move throughout the country. So, and the modifications to those codes can be significant. So here in Ohio, just again, a brief review of code history in Ohio. 1911 is when there was any type of legislature for construction. And as we moved into the 50s, they developed the Board of Building Standard, an Ohio building code, not the same Ohio building code that we know today, but an Ohio building code specific to Ohio. Ohio didn't really get on a national platform until the late 70s. After the OBOA requested that BBS to adopt that model building code. And in the late 70s, 1979, OBBC finally adopted a version of the BOCA National Building and Mechanical Model Codes. There was a little bit of a grace period there to get people adapted, but since the late 70s, we have been on these national-based codes. But there again, if you're looking at buildings that were built in the 30s, 40s, and 50s, there was very little regulation at the time, and that's inherently part of the problem. So historic buildings, what is a historic building? And that the takeaway on this slide is it depends on what code you're in. And we're going to be talking a lot about navigating through codes and definitions and things. And the definitions are important, including that for historic building. They're going to change depending on not only the code book that you're in, but the jurisdiction, and even sometimes within the code itself. If you're dealing with flood hazard areas, that's going to have a little bit different definition for historic building for that application. And this has been a problem. I pulled this note out of the NBS from 1976. The NBS was the National Bureau of Standards. And since this is an Ohio-based presentation, I thought it was interesting that in the Midwest, Cincinnati was one of the pioneers for historic building codes and defining historic building and what it means and adopting and generating some regulations for that. So as I mentioned, the definitions are really important because they're not consistent amongst the codes. Even the ICC definition is taken and modified by the states, and Ohio's done that with many terms. I've just pulled out a couple of the ones that we use relatively regularly that impact the work that we're doing. Even things like existing building. Ohio has tied it to a certificate of occupancy or one that could get a certificate of occupancy. The one that's in the IBC is broader. An existing building prior to the date of adoption, but Ohio has linked it to a certificate of occupancy or one that could get a certificate of occupancy. Even things like maintenance and repairs. I was working with a client that had dry systems that were corroding and at their facilities across the United States. And a lot of the sprinkler contractors were trying to do entire replacements of these systems as a repair. So again, these terms are defined by the various building codes and the fire codes. And it's really important that we're defining the scope and what it is and the categorization of the project. And we're going to be talking about existing building code, and that becomes critical because that starts to get the roadmap to what chapters are govern the scope of your project. But there again, on the left side of the screen, I pulled out a couple of definitions that Ohio has either modified, added to, or created. And it's important to familiarize yourselves with those. In terms of holistic fire protection approach, so a lot of times, certainly in the AE industry, people mention fire protection and they're referring to the sprinkler drawings, which are oftentimes a delegated design and a high-level approach of the sprinklers only. But as we start to look into the codes and certainly old historic buildings and adaptive reuse, we really want to be mindful that there's a lot more going on to fire protection and the level of risk than whether or not a building has a sprinkler system. And even though the evidence of fire sprinkler systems are overwhelming in terms of the benefits and the trade-offs, and you will see that through the codes and standards, with exceptions and whatnot. When we're taking a look at a building, either for a change of occupancy or adaptive reuse or In a case historic building, we need to look at all these different systems. And what are they? There's the passive systems, your firewalls and fire doors and things like fire stopping. The active systems are the sprinkler and alarm systems, and sometimes we'll have smoke control systems for atriums or pressurized stairwells and elevators. These are all the active systems that, based on detection of smoke, systems will turn on and activate. And then you've got the life safety measures as well that also have to be taken into consideration. And a lot of times these fall on the owner side, but emergency evacuation plans, fire safety plans, occupant training, fire drills. We need to take a look at all those things when we're looking at the safety of a building. And when we're talking about historic preservation, we also want to preserve those old buildings and artifacts, and it really is a balance. And I think Ohio has just rolled out this existing building code that's relatively new in how we approach things in Ohio. It's just one tool, but in historic preservation work, we're really trying to do both. It's not as simple as or as complicated as bringing a building up to code that was never designed for current codes and standards. So there's a lot of pathways and a lot of tools we'll be talking about today because we do want to find that balance in historic preservation projects. Even terms like fire protection and life safety systems are defined as well by the building code. And it's important to note too that it's, of course, like with the balance, it's much more than a sprinkler or alarm system. There's a lot going on this slide, but I think it's important because, as we mentioned, the states will often modify the codes, and Ohio has done that. Equally important are all the reference standards back in Chapter 35. And there's a very frequent mistake that is made in design is using the wrong book. And part of the problem is NFPA has so many codes and standards, hundreds that are published. And oftentimes, in fact, most of the time, you're not using the most readily available standard, the most recently published standard. The codes are always on a delay, and again, in Ohio, we just went from 2017 to 2024. These things are formally adopted at the legislative level. So we are, in this case, we might be looking at NFPA standards that aren't the newest, but these are the ones that are legally applied to the project. So it is critical on every project that we establish what the model building and fire codes are and all of the reference standards. This is just a snippet on the right hand of your screen for NFPA. That list is very long. There's also ASME. Anytime there's any other standard or reference in the building code, if you flip back to Chapter 35, it will tell you what edition is applicable to the project and also the specific code reference where it's referenced, so you can you back that up. NFPA 4 is a big one for us. I've got a slide on that coming up. But that's new to Ohio. And then there's some other codes that we will talk about that might not be a direct reference, NFPA 101, 909, 914 for historic structures. And although those are not formally adopted, I can show you some ways on how to get to those. So NFPA 4 has been around for a couple code cycles. At NFPA, Ohio has finally adopted it. And really the nature of this standard comes from that holistic approach again. If you've got a sprinkler system being designed by a plumbing engineer and maybe a fire alarm system by an electrical engineer and a smoke control system by a mechanical engineer, a lot of times these things do not get integrated and they become problematic in the field for testing and construction. The whole point of this standard is to try to get that all worked out with an integrated testing plan, at least in this case for high-rise and smoke control systems. All these systems really work together to create the level of safety. The smoke control system is only as good as the detection that's going to turn it on. So that's really kind of at the heart of this standard. And Ohio finally adopted the 2021 edition of NFPA 4 for high-rise buildings and smoke control systems. And with the reference standards comes, again, if there's a gap there, Ohio skipped an ICC code cycle. So a lot of these reference standards, we're going from the 2016 editions all the way up to the 2022 editions. And there's been a lot of changes through NFPA through there. So I'll just highlight just a few of the bigger ones. We have been using air venting valves on wet systems since the 2016 edition. But, I bring this up because on historic buildings and older buildings slated for adaptive reuse, some of these things you're not going to find. And if you're replacing a sprinkler system or you're adding to, The rules have changed significantly since original construction. Dry and pre-action systems no longer have requirements for galvanized pipe. In fact, the industry has really moved away from that entirely and has gone back to black steel pipe, preferably with nitrogen generators. There's been a lot of issues with corrosion with dry and pre-action systems to be aware of. So if you're dealing with an old structure and you're trying to either revamp or replace an existing system, it's really important that you take a look at where the industry has gone, because there might be changes in material type and system type and design metrics that need to be looked at. Rules for electrical rooms have changed, beam rules. The isothermal maps have been abandoned. So if you're dealing with, certainly where Ohio gets freezing temperatures all throughout the state. So in certain cases, when we're dealing with dry systems, we need to take a look at that as well. A couple of the changes from NFPA 20, it's a big deal whether it's an electric or diesel driven pump. Everything from the fuel hazards that are associated with the diesel pump to the room space and the ventilation requirements. So there again, in an older building, you might have a pump that has been around for 40, 50 years that you're either going to retrofit or reuse, and the codes have changed immensely. A lot of old historic buildings don't even have pump room enclosures anymore, which has become something in current cycles and last few code cycles as well. So as we take a look at those pump assemblies, there again, it's not just about the pump. As we get into NFPA 20, it'll talk about the room and everything that's required for a pump room and water service, et cetera, so on and so forth. And again, when we're dealing with older buildings, we're dealing with many code cycles of changes. 72 has really been come a long way just in the last even 5 or 10 years. System survivability is a big deal. Making sure, and that's basically making sure that some of your wiring and your connections with your fire alarm systems can sustain a fire, particularly in high-rise occupancies or healthcare occupancies. All the terms on system survivability have really come into the code in the last 10 to 15 years or so. We're starting to talk about elevators and use of those for fire service, of course, and then to a lesser extent, occupant evacuation elevators. But with those big design changes in modern day buildings comes a bunch of code changes to make sure that we can do that safely. Areas of refuge requirements, carbon monoxide and alarms have been another big topic within the last, I'd say, 5 to 10 years. And this is really important with adaptive reuse, because we're changing office buildings to then residential. You're always going to get into a requirement in residential now with fuel-fired appliances, with carbon monoxide and alarms. It just wasn't even a thought, even 15, 20 years ago. Other references and guidelines beyond the codes. This preservation brief 51 is coming up on a year old now. This is an excellent document to navigate historic preservation. I'm not going to deep dive into this because I know Heritage Ohio has another webinar coming up in a couple weeks, focused entirely on that. But if you have not seen that, that is an excellent preservation brief. There's a whole series of briefs. They're working on one for wildfires as well. But this is a really good, you can get lost in the codes very easily if you're not used to working with them. These preservation briefs are written in a way that makes things easier to understand. National Trust has some good literature out there that approaches things a different way. We'll be talking about that in a bit. Secretary of Interior standards. GSA, if you're in the federal space, has a bunch of standards, and even the APT Webliography. So more specifically now in Ohio Building Code, again, the International Existing Building Code was published in 2003, but Ohio did not pick it up until this last code cycle. And it's been a big change because we used to go to Chapter 34 for existing buildings, which is in the building code, which has now been deleted, and everything goes to existing building code. Now, some of that stuff has been preserved, and we'll talk about some of the performance-based pathways that is not new material. It's been relocated from 34 into the existing building code. But fundamentally, a big change for Ohio, because what was a short chapter is now an entire book of methodologies. And what it comes down to is, at least with the IEBC is concerned, there's 3 different compliance methods. And one of the things that makes this stand out from other compliance methods is you can only choose one for the scope of your project. And once you pick one, you're kind of stuck with it. It's prescriptive performance and work area method. And that's not to say if you have a large building that's broken up into several projects or different floors that you wouldn't be able to choose a compliance method based on those project scopes. But the way this is organized is a one path type organization. It's worth noting that Ohio deleted an exception that basically the grandfather rule. That's not to say that you can't. There are other places in the code, prescriptively in the prescriptive method that allows you, if it's existing and you're not touching it, it can remain. But a lot of the language on that grandfathering stuff has been either reduced or or harder to use because there's a lot more tools that we have now to be able to navigate some of these design challenges. So there's a little bit of method to the madness with the colors on the screen here. The ones in yellow are ones that you're going to use regardless of what compliance method that you're using. All compliance methods are going to use Chapter 2, 3, 14, 15, and 16. If you're on prescriptive method, you're going to add Chapter 5, 13. On performance, you're going to use that. The ones for work area are in green. These are all lumped together. And what's you have to really kind of understand about it is those are only for work area methods. So it might be tempting to open up the book, see Chapter 12 as historic buildings, jump right to historic buildings and start looking at project requirements. But that is only good for work area method. In fact, one of the things that we're working on the APT code committee now for this next ICC code cycle is trying to get all the requirements for historic buildings into a single chapter for all the compliance paths. So I did just attend the hearings in Orlando a few weeks ago, and it looks like that might have some legs. There's a series of hearings that are needed to get that passed. Ohio wouldn't see it probably for another 3 to 6 years because we've just gone to this new code last March. But that's something that's in the works. So as it stands now, your work area method is going to be Chapter 6 through 12, and that's solely the work area method. A change of occupancy is this is another one. It's important to know that a change of use is also a change of occupancy, and really the focus is on fire risk. You know, it used to be that if you back in the old Chapter 34, well, I've got an A3 occupancy. We're not changing the occupancy classification. We're remaining A3. A lot of this stuff can remain. The existing building code drills down a little further, and we really need to take a look at the fire risk. Is that A3 of the same occupant load, or you got to still take a look at your number of egress doors and your occupant load counts. And the focus really on an existing building is more about the change in the fire risk. And even if you see there on the screen, by definition, a change of use is a change of occupancy. And then in Ohio, again, they're calling out that a change of a use group within that group, they're looking for the increase in fire risk from an assessment. So it's not as simple as saying, well, we've got a certificate of occupancy for A3, we're remaining A3. You got to do a little bit deeper dive than that. So now we're going to kind of walk through existing building codes. Before we do that, are there any questions so far on the code history? Why we're doing this or anything on code development for how we got here so far? Any questions so far, Devin?
Nope, no questions.
All right, sounds good. We'll launch into provisions for all compliance methods. Again, these are for all the methods. I just highlighted a couple here against smoke alarms and carbon monoxide detection. These are going to come up on anything that is a Group R or Group I occupancy. And we see that a lot with adaptive reuse with the trend of turning offices into to residential. And that's going to come up, again, on all compliance methods, regardless of what you choose. Prescriptive method is probably the thing that we're most familiar with in Ohio. It's going through and bringing certain building elements up to code based on the nature of the work. But we're first going to categorize that into what we're doing, either as an addition, an alteration, a change of occupancy. And then there are some exceptions for historic buildings that are covered in this chapter too. You're going to find yourself, if you do prescriptive method, going back to, it's going to send you back to the Ohio Building Code for new installations and the scope of the project. Fire escapes, we're still using fire escapes in some cases in older buildings. So there's a chapter on that. And this is the one where you'll be most likely sent back to OBC with some exceptions on historic buildings. And there again, the change of occupancy is based on the fire risk. But within this prescriptive space, there's still some flexibility. So it's not as simple as saying that the existing stairs have to meet codes. And that's really kind of the point of this prescriptive based approach. There's some leniencies in here. I pulled out just a few examples. Stairs, where the construction does not allow reduction in pitch or slope. Historic buildings often have a grand staircase that we want to keep, and the codes are going to let us keep that, provide some flexibility. Things on live loads, snow and wind loads. There's some leniency here on the old standards. We also need to make sure that we're looking at the Ohio Fire Code. This often gets missed sometimes in design because the fire code really doesn't come into play until after the certificate of occupancy and then is enforced by the fire department. But we are the fire official. But it's important to take a look at that because there are certain, and there's actually a really helpful chart in Chapter 11 on existing buildings that kind of goes through, this is just a snippet of that chart, but it goes through a lot of different topics on your occupancy, and it'll let you know if something is required or not. There is a provision at the front that kind of guides you through whether or not these are retroactive or not. Not everything in this chapter is retroactive, but there are certain things, means of egress, smoke detectors, carbon monoxide detectors, I've mentioned those before. Those are all retroactive. But we use this regularly in our design work too, because the fire code is going to take over at their certificate of occupancy. And it's important to note too that Ohio, while we've gone to 2024 versions of building code, existing building code, we're still in the 2017 edition of Ohio Fire Code. And then on historic buildings here, this is one of the paths. I mentioned that 914, NFPA 914 is not a reference standard in either the Ohio Building Code or existing building code, but this is one way you can get to it. The Ohio Fire Code does reference NFPA 914 for historic buildings and 1103.1.1. So that's just one example that I wanted to highlight on just because an NFPA standard is not referenced in the building code. Here's a pathway to get to it if you need it. We're going to shift gears to work area method now. Work area method, you're typically doing work in an isolated part of a building, and you're basically going to draw a box around that, or in case your work area method, and look solely at your scope of work area. And you're going to first pick what level alteration it is. Level 1 is more of like a lipstick renovation type of thing, existing materials, elements, and fixtures. Alteration level 2 is when you're replacing doors and windows, or your work area is still less than 50% of the building area. And then level 3 is once you get above 50% of a building area, you're going to comply with level 3. And pretty intuitively there, as you get through the different levels, the scope of the requirements is going to get more stringent with the increasing levels. And then we can't forget about change of occupancy. And again, change of use. It might also be a change of occupancy, and it does make the distinction between a change of use and a change of occupancy classification. And then in historic buildings, this again, this will send you to Chapter 12. Chapter 12 is only for work area method, and we'll go over some of the different historic preservation provisions of that chapter. The building official can require a building report. It's implied and accepted that historic buildings are not going to comply with current code. And you'll see that throughout the existing building code in the front end. This written report is just another tool that the AHJ can use as an attempt to have the building looked at, to call out areas that comply and what the compliance method is going to be. And it really does encourage an equivalent level of safety. It's not a black or white code compliant type solution every time. There's some fire safety. There's a dedicated fire safety section in there, and a provision that lets you use sprinkler systems or fire extinguishing systems to mitigate a serious hazard. The exception is that it can't be a substitute for a number of exits. So if you get a building that requires 2 or 3 exits, you can't put in a sprinkler system and use that as a justification for a single exit. But there's some other flexibility as well. Door swings don't have to swing in historic buildings in some cases. Where we're used to doing that now with current code. So there's just some examples of some of the flexibility that's provided within historic buildings. Interior finishes, there's a lot of flexibility on there. There's several locations throughout the code that lets you use plaster and lath as a substitute, regardless of what that fire rating is. If the code would require you to be an hour and it's plaster and lath, you get a pass for historic buildings. The reason there is that there is some fire rating associated in most cases to wood, plaster, and lath. It could be as low as 15 minutes and as high as an hour. But there again, it's another example of this code providing some flexibility to allow us to maintain the integrity of the historic building while also making sure the building is safe. Flexibility on stairway enclosures there. I mean, we're used to doing 1 or 2 hour rated stairwells, but there's some forgiveness in Chapter 12 there, and glazing, handrails, guard heights, handrail heights. A lot of flexibility there in historic buildings. Exit signs are the same way. There's a lot of different options for exit signs. Photoluminescent lighting's come into the code as well. And even when you get outside some of the, even at the floor level and whatnot, there's ways to use exit signage schemes that may not comply with current code, but there's some flexibility for historic buildings. Building area, again, some flexibility on building area, location on property. There's an occupancy separation allowance as well, where there's 1 hour. We're going to move to the performance compliance method now. And this is a path that's the least prescriptive. And there is a tool that we'll talk about here for evaluating the level of risk in existing buildings. And this can be used whether or not there's a partial change of occupancy or a total change of occupancy. And it's got pretty good application. There are some occupancies like high hazard, for example, and certain high occupancies that this would not be a path for, but this is a good path for a lot of places. Now, this is just one example of a performance compliance method. This did used to be in Chapter 34 of the building code, and this system was developed in Ohio back in the 80s, so it's been around for a while. They took it out of Chapter 34, put it in the existing building code. Again, has broad application. And in this case, you could still use it for I2. It's just that if you use it for an I2 occupancy, you have to use this for each smoke compartment. The basis of this system is to take a look at 3 different categories: fire safety, means of egress, and general safety. And we got to make sure that we have a minimum level of safety provided in all of these categories. So here's just a snippet of the scoring sheet. There's 23 categories on here, and then the subcategories: fire safety, means of egress. We're going to look at all of these components of the building, add up the scores, and find out if the building complies or not. One of the nice things about this method is if you run this method as is in the building and you fail the test, you can go back and see what you can do to pick up points. So I've pulled out a couple examples of that, because automatic fire detection is a place where you can pick up a lot of points, where we've used and deployed the system before. And if you look, say assembly occupancy at an A2 occupancy, the difference between not having any detection at category A of -25 and then category E, smoke detectors throughout your floor area, there's a 34-point differential there that you can pick up just by adding detection. I mean, detection is generally not intrusive, fairly low cost when talking about other means and methods and fire protection and life safety systems. So just with detection alone, you can pick up a lot of points and make your building safe. And the idea there is that you're starting that the fire alarm is going to ring sooner. You're going to start your means of egress sooner, and that therefore the building is safer because you're alerting occupants sooner and starting all those pathways sooner. So there's some flexibility then on what needs to be provided. Corridor wall values is another one. Again, the difference between having no corridor walls and an A2 occupancy in this case is -30. Up on the other end of 2 hours, it's 32 hours, or 2 hours. But there is we're going to do this with all the different 23 categories and go through and try to pick up points enough to demonstrate that we have a safe building. So the code is going to dictate what those minimum scores are for fire safety, means of egress, and general safety. It's going to be by occupancy. Obviously, there's occupancies that are more hazardous, either by occupant load or people sleeping, etc. So they've spelled all that out. We're going to add up the points, make sure we meet the minimum scores in all three categories. If we don't, maybe we take another look and try to develop a design or an approach that has a passing score in all the categories. For mixed occupancies, you're going to do this with separately for those occupancies where your occupancies are not separated. You're going to do this. You're going to use the most restrictive occupancy. So we'll walk through a brief case study here. This was a building in Cleveland, the Rockefeller Building, 17-story high-rise. It was an office building that was being converted to an R2. The problem in this building is that the locations of the existing stairwell created a common path to travel problem and a dead end problem there on the right side of the screen. The left corridor, even though that corridor is longer, it did not have that same problem because of the way that the exits were situated there. So that blue stair in the right, bottom right-hand corner is just the architect's original design of they were going to cut a new stair into the building to meet all of the travel distance and common path of travel requirements. So that's one option that we looked at. We looked at more of a horizontal type bridge corridor instead of a vertical stairway and putting people into the lobby. We also looked at putting a corridor through the elevator lobby because of where a building's required to have two means of egress. Only one can go through an elevator lobby. So we looked at both smoke guards for the elevator shaft and also a rated corridor just to have some options there. Ran all the numbers and found that basically all three of those paths created a path to compliance. So I think we had some additional detection that was in there that, again, back to those, picking up points to get the safety scores. All three options that we worked out gave the architectural team some options for design and have a compliant building, even though if you look a prescriptive method, it looks like you might have a dead end or a common path of travel problem. And even in that case, that's where detection can go a long way to mitigating those problems because you're starting the alert and means of egress sooner. I have another example here on 101A. The reason is because this is organized very differently. Similar approach to the point system, but the way they go about occupancies, I wanted to run through a quick example on that as well. In this case, we had a board and care occupancy that NFPA 101A was just better suited for the project than NFPA 30, or the existing building code performance method, because of the specific chapter on board and care and how they treat board and care. So we had a small facility, Sisters of the Holy Spirit Mother House. This was in Garfield Heights, Ohio. It was an old nunnery that was being converted to mixed use new board and care. And 101A is the assessment. And we're able to get to 101A through chapter 1 of the building code, which allows alternative compliance methods. And that was our justification, is that this system is similar to Ohio. At the time, it was chapter 34, similar to the method, but more appropriate for the occupancy for board and care. So they also had a fire at this facility back in the 40s, so there was some sensitivities there with the change of occupancy and the adaptive reuse of the building. And this is also unique to 101A. They divide board and care into large and small facilities, which was perfect for this job because the second floor had 16 residents. The bottom floor had 16 residents or less, and there was a 2-hour fire separation at the floor. So we were able to treat these as two separate small facilities, which was required even in the OEBC, where similar to healthcare, where you've got to run the analysis for each smoke zone. We ran it all ways as well. We also did a large facility analysis, is 19 units. And again, the big takeaway here, very similar in scope. There's less categories to evaluate, but they just get to the safety scores a different way. Similar approach. There's an additional worksheet with this one that we can't overlook. There's certain things like utilities, heating and ventilation, elevators that need to comply. And then there are things like we talked about at the onset of this. There are, fire drills and things like that we have to, operational things that for the design professionals on the call, we need to work with our owners to make sure there's a plan in place. And for the owners on the call, that's also an important part of fire safety, is making sure that you've got your fire evacuation plans and you're doing your testing and whatnot, and working with your local fire marshal. on that. So the case study conclusion, again, it passed. It was just a couple points shy of the new large facility, but again, with the 2-hour fire separation and the way the building was arranged, we were able to show that it was maintained a equivalent compliance. And there's always going to be some recommendations. It's unlikely that you run an analysis and have nothing to do. In this case, it was, there's a plywood access hatch that need to be dealt with. And they did have a storage hazard in the basement with rack storage that had to come out. So you're likely going to have to do something, even with these performance-based approaches. But it was a compliance path that we were able to get to with 101A. And here's some of these operating features as well, whether you're an owner or a design professional. A lot of times in the design professional and the design part, we don't get into these specifically, but it's important that we work with our clients and owners to make sure there are things that are addressed from the operating feature standpoint. I'm just going to spend a few minutes on NFPA 14 because it's similar but different. So here, the goals are the same. The occupants, the contents, protect physical structure. There's also a focus on resiliency, which can be a big topic for historic buildings. We might only have one of a historic building, and the plans for resiliency become even more important. But what's really different about this, even though the objectives are the same and the historic preservation goals are the same, is you are allowed to use a combination here where there's in the OEBC, once you picked your compliance path, you were stuck. Even by design and prescription here, a combination of these methods is permissible. This is also the less code-like. The OBC and even the OEBC is structured as a code. This one doesn't read as much like a code, and it's why it falls under performance. It's more about creating a plan, a safe plan for your building that covers all the things, height and area, and fire suppression systems, and compartmentation, and the operating features. It's all being addressed, but it's more on a case-by-case basis than it is a prescriptive code. And equivalencies are also encouraged in 914 as well. But it's not a design handbook, and in some cases, it's like I said, it's the least code-like. But when we get into performance-based design, which is another reason I wanted to bring this up, and we start talking about fire modeling and other tools that we have to use, this is a good tool for developing design fire scenarios. When you start talking about fire modeling as a path, the data is only good, the output's only as good as the input. So what you choose for a design fire scenario is critical in those cases. And there is a lot of guidance here on how to do that. The example I always like to use is a Christmas tree in an atrium. That might not be present all year long, but as you're looking at different design fire scenarios, trying to choose a reasonable design scenario that is going to be the basis of the modeling study. So there's a lot more documentation for this, but that's how this is structured. And we already covered the part in OEBC where you have to do a report as requested by the AHJ. So this is already kind of built in there. And this is a case where you put together more of a report that would get submitted with the construction documents to highlight a path to compliance. There's a lot of good stuff in the annex of the NFPA standards as well that are sometimes overlooked. In this case, for historic preservation, there's examples of compliance alternatives, some different assessment methods, and some code exceptions. The Secretary of Interior Standards also encourages, again, we're going for that balance, and they also, in their standards, they encourage alternative means of code compliance for historic preservation. So I mentioned there'll be a separate webinar on coming up through the Heritage on Preservation Brief 51. This is one of 51 briefs. Well worth checking out as well as some resources. The National Trust has some resources as well, and this goes about things a little bit differently as well. It starts to get into different fire suppression types, water-based, non-water-based, conventional high-pressure mist. Mist systems really haven't taken off that much in the United States as much as they have in Europe, but there is a path, and it's especially with everything happening now with the PFAS problem, and people are pulling foam systems out and clean agent systems out. there could be a path for water mist more prevalently here in the United States. But this talks about things even like fire preventing ignition and limiting combustibility. Again, not as much code-like as it is a guideline. There's different design tools and approaches that you have too when working with historic buildings. Design by MEP is an approach. That's probably the one that's most commonly used, and it works for a lot of cases where it's largely delegated design to suppression alarm contractors. But as the building gets more complex and have more complex issues, and again, this is where NFPA 4 comes in. There's some other options to deal with that. You can still do delegated design by incorporating a fire protection or life safety specialist in the design team. You could do design by contractor. And then there's code minimum versus other things too. And it's a lot of times what you're going to get with delegated design by MEP, you're going to get some of the bare code minimum on projects, which might work really, really well for some project types. I think with historic buildings and adaptive reuse, where there's a lot of different code compliance issues. And also, as I mentioned before, the material types and types of systems that we use with sprinkler systems and the galvanized pipe and black steel pipe issues. There's a lot of different issues to uncover in a historic building, and we all want to also make sure that they are working together. Then on the performance-based side, fire, smoke, and egress modeling, we do a lot of engineering judgments, but particularly for older buildings where there's an older assembly that might not quite fit into a UL design standard. How can we do an engineering judgment to figure out what this rating is, or it's got using both what the code allows us to do with some of the permissions and assign a rating on that assembly. And then, fire risk hazard assessments at a larger scale. So briefly, there's with fire modeling tools on some of the simple models, you might be able to just say you got a 4-story box atrium. A hand calculations might work in that case. But as soon as you get out of the either a box atrium or you start to get up into taller buildings, you really need to get away from those. Those are there's criteria that go with those documents that the engineer should know, but it is not as simple as those have their time and their place. The hand calcs for very simple box type buildings. You start getting into more complicated geometries, things like outdoor and indoor temperature, stack effect. There's a whole list of things that have to be looked at as you get into higher buildings. Those factors become more prevalent, and then which in some cases requires fire modeling. And there's different programs to be able to do that. CONTAM is what we use often for stair and elevator pressurization. That is much more simple to operate than some of the FDS models. But when I first started in this business more than 20 years ago, we would have a desktop computer that would run some of these CFD models for days at a time. 20 some years later, those same kind of things are done within hours or minutes, just with the computing power and the technology. So these tools have really come a long way in these modern tools that we've used that we didn't really have access to as readily 10, 20 years ago. And then even things like theaters here, we can model with BIM that's happening now, model a specific project, figure out how long it's going to take to evacuate a space, whether it's a theater or any occupancy. And at the same time, we're taking a look at fire growth, in this case, a stage, how fast is the fire growing, and the toxicity of the smoke, heat, and gases, and doing those things at the same time. And can we evacuate the occupants before the fire gets to a point where it's no longer tenable? Other tools, again, heat transfer analysis, timed egress, fire resistance. We have a lot more modern day tools now than we did just a few years ago. I pulled this out. I'm registered in the state of Texas. I pulled this out more as kind of a summary of, a lot of times, particularly with older buildings and historic buildings, it might be tempting to want to go sit with the building official and ask them what they want to see. But I think over the years, the projects that really go the best, and even from a roles and responsibility standpoint, for the design professionals on the call, including myself, we're being hired by the owners and the clients to prepare the plans and the different options and the solutions to then present to the building department to review and approve. And if for the owners on the call, that's in your best interest to make sure that the design professionals that you hire are doing that space. Texas put out this brief, again, it looks like last year or so, because this has become such a problem where designers were going into their offices, and this is not just a Texas problem, which is why I wanted to pull it into this presentation, about design professionals going in there and using basically the code review authority as either a quality check or to let them design the design process. And this becomes even more exacerbated and important on historic buildings and those for adaptive reuse. There's some complicated design issues that we need to navigate. For the design professionals, we need to come up with a solution and work together on those and present them to the AHJ. It's the AHJ's responsibility to approve them. And of course, the owner of the building is part of that process as well. And we always encourage meetings with the fire department and the building department early and often throughout a design project. But the way those meetings go is we really should be the most successful meetings and projects are the ones where the design professionals are really driving the conversation on compliance. So in summary, there's many paths to compliance. It's important to establish not just the codes and standards, but also your approach. It's the existing building code is 3 different approaches, and you have to pick one. And establishing those at the onset of the project, and being mindful that the definitions are different, the criteria are different as you move throughout your approach in the space. Think holistically to the extent you can about fire protection and life safety, particularly for existing buildings. There's many other systems and fire safety things that we need to look at from the passive and active systems, firewall, smoke control, fire stopping. I did not mention this, but one of the other big changes in the existing building code is for Group R occupancies. A lot of these adaptive reuse projects, I think it's 250 occupants, now are on a special inspection list. So those fire stopping systems have to have a special inspector on a project. So a lot of those mid-rise and high-rise residential conversions, and it's because of the importance of all that compartmentation. That compartmentation is in some cases just as important, if not more so, than the sprinkler systems. In fact, in Europe, it's the opposite. They rely a lot on compartmentation. So again, back to the holistic approach, it's all important. The sprinklers, the detection, the fire stopping, the compartmentation, the UL assemblies, that it goes into the holistic design approach for the building. And we do want to strike that balance. So we want to preserve the historic preservation of our facility and the contents, and also make sure that the building is safe. And both can be achieved with the tools that we have and the resources that we have available in modern society to be able to do that. Challenge yourself on the grandfather approach. There is a time and a place. There are places in the code that still allow that concept, but that hole is closing a little tighter, and part of that again is because we have different is the existing building code, as we have these other performance tools and resources to use. Relying on the grandfather approach is less of an issue. There's other tools that we can use to take a look at that, and then being mindful of our role and responsibilities as in any project, whether you're an owner, an architect, an engineer, or on a historic preservation board or an HJ, and we all have a role to play. And when we all fulfill those roles, the projects seem to go a lot better. So I thank you all for your attention. There's a few minutes left for some questions. Happy to answer any questions you have. And thanks again for attending today.
Thank you, Scott. And I'm going to send out right now, in case anyone signed on after the introduction, the sign up for the AIA credit for this. Please just fill out those couple questions, and we'll get that sent over to Scott so he can get your credit sent out to you next week. So Scott, we have one question here, kind of a reverse order of building change that you had mentioned earlier. So instead of going from office to residential, we have a situation here of a historic residence that the new owner wants to use as a smaller event space. Do you have any tips or thoughts on that sort of situation with such a change in occupancy?
Yeah, I mean, the first thing is, I don't know if that's an owner or architect, but the studies can go a long way. I think the first thing I would do before getting too carried away with the actual details of the design is just do a quick study, a code study, to determine all of the the changes that are going to take place. Like an R to a, he's going R to A, you said?
I think so,
Residential
yeah.
assembly. Yeah, so like assembly spaces, you're going to have more people generally, and not always, but assembly is more people, so that affects it means of egress, everything from travel distances to number of exits and that type of thing. And you want to get a good feel for the conversion. There's various firms as well that have rolled out one in particular, an architectural firm that's rolled out. There's the fire building code that we talked about today. You definitely want to look at all those. And then there's the other parts of the suitability for the reuse where they're looking at, I think they call it a scorecard. But all that to say is get ahead of this and find out, do it, the study dollars and the study is the code study to figure out everything that's involved here. It's going to save you lots of time, both in design and money, and trying to figure out what it's going to take. But those are some of the issues, and fire compartmentation. There's going to be a trade-off there. In some cases, going to assembly, it might be easier. You might have less fire-rated construction. In some cases, it might be harder because assembly occupancies have generally more people and more exits, et cetera. So all that can be fleshed out in a study that'll before you get too far down the line of plans and meetings.
Thanks, Scott. Next question here is there a publication which identifies archaic assemblies to determine existing, and then this is parenthetical, old school floor, wall, ceiling assemblies?
Yes, I skipped over that I had a bullet in there. I think it's resource A of the Ohio existing building code. You can find this a bunch of different places too, but it's actually been picked up in this last Ohio existing building code. I think it's resource A. It starts with Appendix A, so you got to get down a little further, but it's the archaic materials. Get the formal name of it, but I would check the Ohio building code, Ohio existing building code 2024 resource A.
Thanks, Scott. Next question here. So we often, encounter like a lot of small building owners, historic building owners, that have had a visit from the local fire marshal, and they have those kind of questions. Then it's like, what can people be doing now before they get those visits to start working on their fire protection systems and with kind of a budget consciousness in mind with that?
Sure. Yeah, it's always a good idea to try to have a relationship with your local fire authority. I've seen, in the past, I've done a lot of industrial work, and they would invite, I mean, there are lots of high hazards there, but the same would apply for, residential, really any occupancy. They would just invite the fire marshal in to do a walkthrough of their facility. And the thing to keep in mind too is in terms of just with cost, the comment on cost. A fire marshal does not have the authority to enforce anything beyond code compliance. It's important to keep that in mind. So you're not opening Pandora's box by inviting a fire marshal in that it's not going to be subjective and arbitrary. They might have some things. Now, the downside is they could find some things that are violations that you'd have to deal with, and that might be the short-term downside. Everybody wants their buildings to be safe, but those meetings, generally are well received by the fire marshal. And if you can get out ahead of it, and start a relationship with a fire marshal that way, again, there's some good and bad in there depending on the condition of your building and whether or not there's violations and whatnot. But it's always going to be better if you're being proactive about it than reactive.
Okay, Scott, our next question here is when Ohio State Code and City Building Code come into conflict for historic buildings in their updated use, such as going from an office to assembly or office to residential, how is that resolved?
So the rule of thumb is that the most restrictive often wins, but the other place to go, and this is where working with your local jurisdiction is really important. So there's going to be an entity, and AHJ is a general term in the code, but that could mean chief building official, that could mean fire marshal, that could mean historic zoning board, and really finding out making sure the very first thing I would do is find out what jurisdiction you're in and what codes are legally applicable. And that is a step that people miss because it might not be, make sure they're in conflict first by following the path of, okay, we're in this jurisdiction, we got to abide by these codes. And then if you do find a conflict and they do happen, work with your AHJ on that. There's been an unwritten rule in the city of Cleveland for a long time about no elevator shunt trip, and it's like it doesn't even, I don't, to my knowledge, I don't even think it's, I've never been able to find it, but it's just been something that has been gone on for years. So I think when you find a conflict, the prescriptive codes would tell you the most restrictive applies, but this is the time to sit down with once you've verified the codes actually apply and there's a conflict, sit down with your AHJ and your design professional if you're not a design professional and get that resolved as a team.
Thanks, Scott. I'm not seeing any more questions. So thanks once again, both to Scott Volkerding and Osborne Engineering for doing this webinar today with us. It was absolutely wonderful information. Just for everyone's knowledge, we'll be sending out the recording of this to you tomorrow. As well, I'll include the AIA sign-up sheet. If any of you are still hunting for your number that need to give to Scott, you can fill it out in the next couple days, and we'll get that sent over to Scott as well. So before we go, I just wanted to also thank the Ohio Department of Development for in part sponsoring webinars like these with us. Thanks to Scott again. Have a good evening, everyone, and thanks, and we'll see you at our next webinar. Thank you.
Thanks, Devin. Thank you all.